Hey everyone, welcome to this live stream where I talk about C++ and what I believe is a sane way of using it. I've been programming for over 30 years now and written probably a few million lines of code in that time. And I'm currently maintaining the 10x codebase, which is almost 500,000 lines of code that I've written. And hopefully in all that I've learned something that I can pass on to you. So let's get on with it. Last time I said I would put together a spreadsheet of C++ features and briefly go over all of them. So I've done that, which is here. I'll go over it later on in the stream. But first, I said last time I was going to look at designated initializers. But before I do that, I'll just mention something about range-based for that I've been just noticing in the last few days, actually. I've kind of been missing the index in the debugger. So as I'm debugging a range-based for loop, I kind of miss the fact that I can't see the index that I'm currently on. I had a bug where it's iterating through a list of fonts earlier, and one of them was bad. And I could tell in a debugger it was bad, but it was tricky to find out which one it was in the actual list because I had no idea, no way of looking at an iterator or an index to find out where it was. So it's just a bit annoying. So anyway, it's just something I noticed while I was using the range-based for. But I'm going to carry on using them. It's only a minor thing, but it's just something to keep in mind. If you do think you need an index, it's kind of useful, to go back to the old indexed for loops. Anyway, so someone asked me to look at designated initializers, a new feature in C++ 20, I believe. And I'm not going to spend too long on it because I've decided not to use them, as you probably expect, because it's a modern C++ feature, and I tend not to use the modern features. But I had a look at it, and let's see. That's odd. Okay, let's switch editors. So, hopefully you can see that. I just try to find, because I think it's useful to always look at real examples in real code rather than trying to make stuff up. So I just decided to try and find somewhere in my code where I've used a struct and I'm initializing it and passing it into a function. So as you can see, I've got a bookmark here, which is a bookmark in 10x editor, which is just a struct with a string and an int and a handle. So it's very simple. And I just create it here and initialize it here and then pass it into the functions, add function. So as I'm sure you know, designated initializers, you can initialize them specifying the name of the value you're initializing, and you can leave them. They have to be in order, but you can leave them out if you don't want to, and they'll be 0 initialized. So in a way, it's a nice way of initializing a struct instead of just having the values. You're actually showing what you're initializing. So yeah, that's okay. It's slightly odd syntax for me. It's not something I'm used to, just having a dot in front of something. It's a bit weird. I mean, basically, you're leaving out the variable name here, and using commas at the end rather than semicolons. So to me, already it's a bit different, and I'm not used to it. So the other benefit is you can pass them in directly, so you don't have to create it first. You can pass it, and I've noticed a lot of examples that I've seen of people using them. That's what they'll do. They'll pass them directly into a function call as an argument. So in a way, it's like passing 3 variables to a function. but it's nice because you're showing the name of them rather than just having arguments that you can't see if you're passing it in. And a lot of the time people omit the name. So as you see down here, I've got the name. You don't actually need that, and the compiler will work out, a bit like auto, it works out what the type of this is because it knows what that add function takes. I don't like that because I want to be able to see the type of the thing I'm passing in. I want to be able to click on it and do go to definition so I can find it in header and see what it's all about. So I'm not a big fan of not naming it, but you can name it obviously if you want there. And yeah, I mean, I don't know what you think, but I still prefer the old traditional method of doing it. It's a little bit more typing because you're doing bookmark dot each time instead of just dot. But I think it's nicer because you're just doing it the same way as everything else. Yeah, I don't know. It's not something designated initializers isn't something I've looked into a vast amount. So there may well be cases that I'm not thinking of that I could use them. But in my entire code base, I can't really think of anything other than this kind of case where I'd use them. And to me, it's not immediately better. It may be better in some cases, definitely. But like I would say, in C++, there are already sort of 10 ways of doing the same thing on lots of different things, and it's already a complex language. Is it worth adding another way of doing something just to be slightly more precise or slightly less typing in a certain case? And for me, I haven't found a case where it's so useful and so nice it's worth adding a whole new feature to my language. So I'm probably not going to be using them yet. I may change that in the future if I come across something. I know if you're doing lots of, say, DirectX work and passing in structs or vectors and matrices or whatever, they probably are more useful. But in my code base, I just haven't really found a use for them yet. So I'm going to hold off on using them for now. I was going to look at, I did create a quick test to try a few debugging things. Let's see. Yeah, someone said it just one good thing is it initializes not unspecified fields to 0, which is useful, I will admit. I'll come on to that in a minute. So from a debugging point of view, that's fine. If a simple example like this, so I've created a bookmark which is the same as what I just said, and that's the way I would normally do it. This is the new way, and yeah, it's okay, it's fine. I can step into it. And that's good. And I've got there the bookmark struct name there if I want to go to definition on it. Now, I'm not a big fan of putting stuff into functions like this. Even if I had, say, bookmark had a constructor, I wouldn't normally do that. Sometimes I will, but usually I would go for this method. I know it's more typing, takes a lot more space, but very often I find it annoying, especially when debugging, when I'm stepping into something and it's stepping into the constructor. Obviously it doesn't have a constructor, but if it did have a constructor here, it's going to step into that, which is a bit annoying. And also I can't see the value. So when I'm debugging the old way, I can put this in the watch window and check it's got all the right values. Because I mean, I don't know what getLine index might be returning. I want to see that it's correct before I step into the function. And I also want to put a breakpoint here rather than because I can skip all this. I don't want to debug this, I just want to debug this call. And I want to know what bookmark is before I step into the call. So you can see that in the watch window down here. And when I step in, it's literally just going to step into that function and nothing else. So, if I had something like this, it's just going to be very slightly more annoying because it's going to step into this. I don't care about this. What I want is to step into this function. So I tend to not put complicated stuff in function calls. And I just find it so much easier when I'm debugging. I can skip over big chunks of code I don't care about and just debug and look at the code that I do care about. So that's my one reservation already about using designated initializers in function calls, which is what a lot of people use them for. It's not so bad when you say just one function, but say you've got 5 or 6 functions here, it's going to start to get really annoying when you're stepping into this, because it's going to step into those as well. But anyway, that's just a minor thing. What was I going to do? Yeah, I saw some code which had a big, long initializer being passed into a function, much bigger than this, and somewhere in it, it had an if-def to disable or change some code. And I was thinking, okay, that's fine, but what if I want to, say my editor ID hasn't highlighted it like this, to show which one's been called. Say I often want to just put a breakpoint in here or here to see which one is getting hit. And you can't actually do that in this because it will just move the breakpoint down here. You can't actually do that. Whereas if you're doing it up here, you can set a breakpoint wherever you like and step into whatever you want. It's just, for me, a whole lot easier to work with. So I'm not a big fan of stuffing stuff into function calls. Yes, it's less typing. Yes, you can squash it into less space. But for me, from a working point of view, it's harder to work with, I find. Someone did say, why don't you just stick a breakpoint in the actual function itself and then you can see it. But 100 things might be calling this function and on lots of different threads, and I want to find out what's being passed into this function in this call. So here I can't look at bookmark at all and see what it is in the debugger, which I find problematic. I would much rather have it all laid out and then I can see it in the debugger in the watch window. So there's just a few things I thought of while I was looking at it. I'll come on to the comments in a second. I'll just finish this. Like someone said, the nice thing about it is it does zero initialize. So for example, say bookmark is just a struct without a constructor. Obviously, I hope you can see my watch window, it's a bit small. The marker isn't initialized, it's just garbage value. Whereas here in a designated initializer, it is zeroed, which is nice. It's better. Obviously, I could write a constructor for this and zero initialize everything. And in a way, because the initializer stuff comes from C, I think it was added in C99, and obviously C doesn't have constructors, so it's like a different way of doing constructors. And I've got nothing against that. I mean, I'm sure we could find a better way than constructors. And I like the naming of stuff, where you can set the name and stuff. That's good. I mean, I would like that in normal function calls, to be honest, where you could name the arguments to show, because often you're passing in a true or false for a bool and you've no idea what it's relating to. So it would be nice to have that in function calls. So that's quite nice. But it is another way of doing the same thing that you've already got in C++, with constructors. And also in C++, it's not quite so useful just to zero initialize things like it is in plain C. So yeah, just some things to keep in mind. I'll keep you updated if I ever change my mind and do find a case where they're useful. Also, I'm not using C++ 20 yet anywhere near, so I'm not going to move to it just for that. So for now, I'm not going to be using it. Okay, so I think that's all I had to say on that. I'll just catch up with the comments. So someone said they think it's nice initializing 1,000 structs for working with Vulkan. Yeah, like I said, if I was working with Vulkan or D3 or something, I may change my mind if I'm doing, because I don't do an awful lot with structs. It's only occasionally that I use structs, like in this bookmark example. So I'm willing to admit there may be cases where it's more useful. But I would still say consider doing it the old-fashioned way and see, because I mean, some people say it's nicer because you can see the name of the thing you're initializing. Well, in this case, you can see the name of the thing you're initializing. It's just the same. Yes, it's a bit more typing because you've got to type these, but you can still see what you're initializing, and you can still zero initialize stuff in a constructor if you want to. So you can do exactly the same thing in a different way. It's just using a different syntax. It's do you like that syntax? For me, it's kind of different from anything else, so I'm not a big fan of it. So someone said if you have a struct with default values inside a struct which does not initialize it with a default value, then you create an add struct. The inner struct is not default initted. Okay, that's interesting. I didn't know that. Something to keep in mind. Yeah, I'd have to double check on that. But again, it's one of those things that you kind of have to know more stuff. You have to know how it works and when it works and when it doesn't. This you don't have to know anything about. Someone who's just learned C++ and a few days ago would understand that code, whereas this, yeah, you might need to check some stuff. So someone's saying it does initialize the default value. Okay, it may be, I mean, this is a very new feature in C++, so it may be that they're still updating it and fixing. Yeah, so it sounds like it does work now. But again, keep in mind it is a very new feature and may have some issues still that isn't fully supported across all compilers. So someone's saying it's more error prone to code reordering because while shuffling the code around you can misplace a field. I guess you're talking about this where you can, well, I don't see why reordering would be an issue with that. But yeah, I mean, I guess you could accidentally delete a line or something and not notice. But again, the same thing here, you could delete a line and it would just zero initialize it and you wouldn't notice. So I'm not sure, maybe I'm missing what you're saying. But anyway, I'm not saying they're terrible and I'm not saying it's bad code if you use them. It's not bad, and I guess you could get used to it. Like I said, the main reason I don't is because I'm just not a big fan of putting stuff into function calls. I would always much rather put it outside and then pass it in, just for the ease of debugging. Someone saying it's annoying I have to specify them in order. Yeah, it's funny I guess if they're names, I would have thought you shouldn't have to do them in order. I know you do, but I don't see why they made that restriction. If you're naming them, surely you could pass them in any order. Obviously, if they're not named, they need to be in order. But yeah, I'm not sure why that decision was made. But anyway, they're kind of like another way of doing constructors, really, because there's nothing you can't do with a constructor in C++. And like I said, they're coming from C, which doesn't have constructors, so it's a way of constructing something with a different syntax and a different way of doing it. And like I said, in some ways it is better because you've got the names, but in other ways it's just another way of doing the same thing, and they're not replace it. You couldn't say I'm going to use initializers everywhere and not use constructors if you're using C++, that is, because there are times when you have to use a constructor in C++. So it is yet another way of doing the same thing in an already very complex language. But anyway, that's just my take. So it does. Oh, so it doesn't apply to C99. That's interesting. I didn't know that. The order of initialization, I guess you're referring to. Yeah. Yeah, it's funny. I mean, it's possible I'm just missing cases where it is really useful. But I've looked at a lot of code online, modern code that is using it, and nothing is jumping out at me. Oh, I must move over and start using that. So yeah, maybe if I'd started with them from when I first started programming C++, maybe I would just use them and it would be fine. So like all these things, it might just be I've been doing the stuff the same way for so long that I just don't want to change. But I do take some things like range-based for loops I started using. So I'm not anti everything. I'm just always evaluating, is this so good that I really want to add a new feature to my language? And yeah, in this case, I'm deciding not to. But like I said, I may change my mind, especially if I'm working with, like someone said, like Vulkan with lots of structs to initialize. It may well be useful. Okay, so unless anyone's got any more comments on initializers, I think I'll move off that. Tenex has come back. Having some few issues with Tenex at the moment. I guess I'm in the middle of doing stuff with it, so that's why I'm using Visual Studio at the moment. Right. So looks like nobody else has any more comments on that. I'll move to my big spreadsheet that I've been putting together. Hopefully you can see that. There's a lot of lag on this screen. Anyway, so what I thought I'd do is I thought I'd just list every kind of feature I could think of in C++ or major ones that might be interesting to mention. I'm not mentioning every single feature in C++ because that would take a bigger spreadsheet than this. And I'm not doing it by the actual features in the standard. I'm literally just thinking off the top of my head, what do I use, what don't I use? And they're in no particular order at all. I just put them down as I thought of them. I've left off a lot of the really modern features, like in C++ 20, like modules and stuff. Actually, no modules are there. But you can safely assume if it's a very modern feature and it's not on this list, I'm not using it. And that might just be because I haven't looked at it yet. And obviously, I'm not writing down every single feature of C++, like I don't know, ints and for loops and everything, just because you can just safely assume I'm just using all of the normal features in basic C++. So these are just the more interesting ones that might be worth talking about. And what I thought I'd do in this stream is just briefly go over them as quickly as I can, mentioning a few things about all of them. Ask me questions as we go, and then in the next stream we can pick one or two of them and go into much more detail on them, and I can show you examples in my codebase where I do stuff in a certain way, and we can discuss that. So unless anyone has any questions, I'm just going to quickly go through. So just the color coding, obviously green tick means yep, use all the time, no problems. The orange tick means occasionally maybe use, but try not to ever use. So I'm not ruling them out as never use, but try not to ever use them. That's my sort of thinking on this. Obviously, red means never. And yellow means, yeah, use them sometimes, but hopefully not. I try and limit them as much as possible. So that's kind of what they mean. Hopefully it's fairly self-explanatory. So classes, I mean, someone did ask me, why do you use classes? Which I thought was an interesting question. It's not something I've asked myself for sort of 30 years. But for someone who uses straight C a lot, which some people still do, a lot of people still do, it's a fair question. And I will go over it. I think I'll do a whole stream on classes and how I think of them, because I think it is a valid question, and we do have to, I think, go back to basics and say, well, why are we doing this? I think it's a good question to ask. Inheritance, yes, although maybe I think I'll make that a yellow, because I do try and limit inheritance as much as possible, and I always prefer containment over inheritance. And again, that's another thing I could probably do a whole stream on. So inheritance, yes, but try and avoid it as much as possible, which kind of goes against how you're taught C++ in school or university or whatever, because that's the first thing they always teach you about C++, but it's something you should use with caution. Multiple inheritance, try and avoid at all costs, but occasionally you have to use it, but pretty much avoid it. Don't do that. Access specifiers, public, protected, private, yes, I think they're very useful for the same reason I use classes. They're very tied together, so I'll talk about that. STL, obviously no. Well, I say obviously, but a lot of people use it. But if you want fast build times, don't use STL. And if you want manageable debugging or build error message, don't use STL. Write your own. It's not that hard. I'm not saying write your own STL. I'm saying write your own containers as and when you need them. Virtuals, yes, but again, I'm going to change that to yellow. Limit virtuals as much as possible. I mean, back in the day, they were very slow to use. They're not so slow these days on modern CPUs, but still, if you don't need them, don't use them. And they're more like a last resort rather than a first resort, I think. Struct, yes, definitely. I use structs when I've just got plain old data and don't need constructors or whatever. And just like I said, that bookmark example is a good example when I use a struct. References, yeah, I like references. Pointers that basically can't change a value. Namespaces, yes, I like namespaces. I like to organize stuff and avoid scoping issues and stuff like that. Enums, this is C enums, and I put an X next to that. Although I'm still using them, I'm gradually converting over to enum classes. But again, I've been annoyed today about enum classes because I was using a count field as the last field in enum to say how many things were in enum, and using that count to initialize the size of a static array. And when I switched over to C++20 compiler, it complained about that because I had to cast it to an int. It's really annoying. It's such a common thing to do, to treat enums as integer values. It really shouldn't do that in my view. But anyway, I'm going to stick with them for now and try not to use old C enums anymore. Break in for loops, etc. Function overloading, yes, but probably again I'll make that yellow. Try not to don't abuse it. You know, it's so easy to abuse it and start having overloads for everything. Range-based for, yes, like I said, recently or the last couple of years I've switched to using them. I'm gradually converting over. A few things I don't like I said earlier about the index, it's a bit annoying sometimes, but they make the code so much cleaner and easier to write and read. But I still use indexed for loops. And again, I could go over, I'll probably do a stream on that, when to use an old style indexed for loop, because they're still very useful and still should be used in my opinion. Because I've heard some people say, never use them, you don't need them anymore. Well, yes you do, and they are useful. Continue, same as break. Occasionally, I often do that these days. Null pointer, just to say don't ever use the old null anymore, always use null pointer. I'm gradually converting my code base. I've still got lots of old style nulls in there, but it's type safe, so it's better than the old school define. Unions, yeah, they're good. Definitely use those. Iterators, I do use them, but not that much, especially now I've got the range-based for loops. So, in STL, iterators are everywhere and they're all standardized and everything. I'm not a big fan of that. But yeah, sometimes using iterators. Okay, so I'll take a breather. Done the first column. That didn't take too long. Yeah, so question, yellow means sometimes, but not always. Yeah, yellow means I'll use it, but try not to use it too much. Like, if I'm using it, I'll think, could I use anything else instead of this? And if I can't, then I'll use it. but I'll always kind of check. Whereas green just means use without thinking, really. You know, you can use green stuff wherever you want. But yellow means use sometimes when really necessary, but try not to abuse it. Because some people, for example, smart pointers, they would put as green and say use them everywhere. You should never ever have a raw pointer. Well, that's not me. That's not me at all. I'll use smart pointers occasionally, but only if there's no other option. So, ready for the second column. Again, like I say, keep asking questions as we go, because it gives me a good idea of what people want to do a deeper dive on. You know, in future streams, we can go over any of these, and I'll try and give you some examples or opinions or some stuff. Someone said he uses references to avoid using the arrow operator. Yeah, that's not a good reason, really. But someone was saying earlier, was it UGGN or someone else, that I think it was Septag, that there isn't any reason to use the arrow operator, which I can't even write in Excel, rather than a dot. I mean, we don't actually need it. We could just use dot for everything. It's only to remind you that you're using a pointer, and I always prefix my pointers with p__ anyway. So just one of those funny things that we just do and don't really think about. Anyway, so auto I've already talked about in a previous stream. I don't use smart pointers, like saying I'll use, but rarely. Like I said, some people use them everywhere and swear by them. I use them only rarely, and if there's no other option. But again, I can show you examples of where I do use them. We can go over that in a future stream. Scoped classes, I often like with the lock scope, where in the constructor it will take lock and in the destructor it will release the lock. So that's what I mean by scoped classes. I think they're really useful. And I do use them in quite a few cases. So I like that constructor destructor thing, which I know when something goes out of scope, it will clean itself up. Someone's asked about goto. Yeah, okay, I'll come to that in a sec. So type defs, yes, I use them a lot. Well, I say a lot, not a huge amount, but I will use them without thinking, without worrying whether I should be using them or not. I guess I could use the using alias instead these days, and maybe I should switch over to that. Something I'll be thinking about. But for now, just because I've always used them, I just use type def. But I don't use them an awful lot. Some commenting about goto, I think. So exceptions, no, they're slow and they're horrible and they're as bad as gotos. No, exceptions are very bad. Anyway, I won't go into that here, so it'll take too long. Lambdas I've already talked about in a previous stream, don't use. Operator overloading, I had that. Oh, that was function overloading. I was thinking that was operator overloading. Yeah, so operator overloading, that's what I was talking about earlier. Use but don't abuse. Constant expression, no. I see people doing very clever things with that, saying this will make the code faster because it's doing it all in compile time. Well, I've never optimized any big code base by putting in a constant expression. I think it'd be very rare for that to ever really happen in the real world. Designated initializers we talked about today. Attributes, I've never really looked into attributes. So possibly could be useful, but yeah, I'd have to look into that. I'm not quite sure what I would use them for, but maybe someone else can give me some examples on that. So bit fields, that's as in, I think I meant packing stuff into bit fields using the colon operator, colon 1 or something at the end. They're very useful, definitely, for saving memory. But obviously, to be aware there's a hit with them on. There's a very small hit on the CPU to do that. Well, there can be. Override, yeah, use override whenever you're overriding a function, obviously, because it will tell the compiler will tell you if you're not overriding something that you think you are. Now, friend, I hardly ever use, but very occasionally. It's probably used about 5 times in my entire codebase. And I can go, when I talk about access specifiers and classes, I can go into that a little bit more. So if you're using friend everywhere, you've probably done something wrong in your design. So R-value references I talked about last week. Don't use const deval, don't use static, yes, static functions, static members, etc. Not a huge amount, but yeah, I don't worry when I do use them. While loops, obviously, do while occasionally. Now, some people say you should never use a do while, it's bad programming. Well, maybe occasionally it is useful to do something first and then iterate on it. But again, I hardly ever do that now. And the few times I have, I've usually restructured it anyway and not used it. But I will use it occasionally. Okay, so that's the second column done. Some saying attributes very useful when doing bare metal coding. Okay, I'll take your word for that. Maybe you can give me some examples. So I'd be interested to know when they can be useful. Inline. Oh yeah, I haven't added inline, I guess. Yeah, I mean, I'm kind of taking it for granted. Definitely. But again, only when it's needed. I mean, it's not actually. I only use inline when it's needed for the compiler to actually compile something. If you've got a class if you've got a function in a header in a class, obviously it's going to be inline anyway, so you don't need to write inline on it. And it's only a hint to the compiler. And compilers these days are so good at inlining that it's not really relevant anymore in modern code. But occasionally you need it just to tell the compiler not to instantiate the function multiple times if it's included in the header multiple times. You can do force inline, and once or twice I've done an optimization with force inline. And very occasionally you can do better than the compiler if you know something is called a lot. And I have done a few quite significant optimizations, even recently in the last few years, by force inlining stuff. But don't go crazy with it. You usually don't know better than the compiler. So only do it if you're profiling and you measure a difference using force inline. So yeah, use with caution. Let's make that a yellow. So someone's saying, Casey Mitori was saying static is completely ignored by the compiler these days. I'm not sure what that means. I mean, if you've got a function in a class that needs to be static, it needs to be static. You can't get around that. If you've got a class, you kind of have to. But maybe that's not what you mean. Maybe you just mean static in a like that. Well, yeah, that's pretty much ignored by the compiler. I mean, it does just mean it's static to that function, that file, I think, but I'm not even sure that's true anymore. So yeah, you don't need that. But also you can do you can do that in C++ now, which is nice because it means you don't have to declare it anywhere else. You can initialize it in the header in the class and use static constant like that, which is, I do that a fair bit, which is useful. So it's still useful in certain cases. Oh, you meant inline, not static. Okay. Yes, inline is pretty much ignored by the compiler these days. So I only use it when I have to. If I've got a header and I've just got a function in the global namespace, for example, and I'm declaring it here, then you have to do inline. Or if it's a template, you kind of have to have it inline, otherwise you'll get multiple instantiations of the function. But other than that, yeah, there's not much use for inline anymore. Yeah, don't worry. Anyway, that was a good discussion on static, even if it was not the thing you were talking about. So let's go through the last column, and then I think we're done. We'll call it a night. So preprocessor, yes, I'll use, but again, try and limit as much as possible. If you're ever tempted to put a macro and do some really clever thing, if I could just create a macro, I could condense all this into one line, and just check yourself and say, do you really need to? Because it's not worth it. It makes code so hard to read with macros everywhere. You're basically changing the language in quite a fundamental way, and it often makes it very difficult to work with for someone who doesn't know the code, or yourself coming back in the future and looking at it. So yeah, occasionally, but hardly ever. Templates are the same exactly for me, really. I use them, but only really in my core container classes and pretty much nowhere else. I think we've all done the use templates everywhere for everything to avoid every single duplicated bit of code and wind up in a complete mess. So try and avoid templates as much as possible, but occasionally they're incredibly useful. So someone's saying, I think GGN is talking about attributes, saying they're useful to align something to 16-byte boundaries or force compiler to map a variable to a register. Yeah, I mean, the kind of, I think they're the modern replacement for things like Pragma in Visual C, which, Pragma's always been horrible, and if attributes are the new way of doing that, then yeah, great. And if they're cross-platform as well, it's even better. So they're basically ignored by compilers that don't know what the attribute means. So I think they're probably a better way of doing stuff we used to do with pragmas. So yeah, I could be converted to attributes, definitely. But yeah, if anyone's got any examples, I'd be really interested to see that. So, explicit partial specialization in templates. So that comes onto templates, really. Yes, use them, but be careful with them. Only if you really have to. New delete, obviously I had to put in there because some people say never use new and delete in modern C++ code. It's the devil's work. But I use new and delete absolutely everywhere, and I know how to mitigate the performance implications of it, and I also I manage my lifetimes very carefully, and that also ties into the smart pointers, which we can talk about. Because some people, if you use smart pointers everywhere, you kind of don't need new and delete so much. So that's definitely something I could do a whole stream on if people are interested. Dynamic cast, no. I do have my own object-based class where I can do checked casts at runtime, so basically a dynamic cast, but I use that very rarely, so I'm not using the compiler dynamic cast support. I don't think anyone does these days, do they? Anyway, I just thought I'd mention it. So const casts, yes, I'll use it, but it usually means I'm doing something dangerous and I should rethink it. Basically, if you're casting and only to cast the const away, it's a good idea to use it because it shows the reader exactly what you're doing, and you can't accidentally cast to a different type. You can only cast away const. So in the few cases where you need it, like you're passing something to an API which isn't const aware, and you're absolutely sure it's safe to do that, then use it, but not very much. Yeah. Static casts, I don't. I just use the old school C casts. To me, there's no benefit in using static casts, really. It's just longer, more verbose, and as far as I'm aware, it doesn't actually give you anything. I did for quite a few years use it everywhere, but I just stopped because it wasn't giving me any benefit. And it was clearer to use a normal old school style cast. So GoTo, well, I didn't actually talk about GoTo, did I? I've seen a few cases where it can be useful, like with error checking. If you've got a function and lots of code paths need the same error handling routine or something, you can do a GoTo in the same function to go to the error handling or the success handling, whatever. And in those cases, it's not terrible. If you're just jumping to the inside the same function, it's not terrible. And I've seen some okay uses of it. And in a way, they're no different than break and continue. They're just glorified GoTos, really. But I would always prefer to try not to use GoTo. I mean, I never use it in my code. I've never needed it. And yeah, that's just my take on it. Obviously, be very careful with it. It's a bit like exceptions. Exceptions are just glorified GoTos, and yeah, it can cause all sorts of problems. So just catching up on the comments, see if there's anything more to talk about attributes. Yeah, so where were we? Don't go to atomics. Yes, now atomics are definitely very useful. You can't do it any other way. If you're doing threading code and you really want to be as fast as possible and not be taking locks everywhere, atomics are incredibly useful. Now I said I never use STL, that was a bit of a lie. The only part of STL I think I use is atomics. And I have my own atomic class, so I only include the atomics header in the CPP file. Because that would put in probably tens of thousands of lines of code into every single file in my codebase if I included atomics header in the header. So I'm very careful at wrapping it. So there's only one file in my entire codebase which includes the STL header, and that's atomics. But atomics are the one thing that STL does do right, because there's never been a cross-platform way to do atomic operations, and there is no other way of doing safe atomics with acquire release semantics than using STL, really, as far as I'm aware, unless you're doing assembler. So they are very useful and very good, and the one thing I do like about STL, that's one thing they got right. If you're interested more in that, watch the old talk by Herb Sutter. It's really, really good. I think it's called Weapons of Mass Destruction or something. It's a very good talk. So yes, atomics are good. I like them. Variadic arguments, yeah, but I only really use them for prints. Oh, and I also use them for my function class that I've shown you a few times. But again, I hardly ever use them in any other case. So yeah, they're useful, but again, don't overuse them. Okay, we're getting near the end now. So const. Now I used to use const absolutely everywhere in the early days. I thought I'm going to be const correct, and I just totally consted everything that could be consted. These days I'm removing more consts than I'm adding. So if it's a trivial case and I can just add it and it won't cause any complexity, then I'll add it. But other than that, I kind of tend not to use them so much anymore. They're just not worth the hassle, because they kind of spread through the code and infect things and just make things more difficult than they need to. But occasionally it's useful. I put kind of const in the same bracket as access specifiers. They're kind of useful occasionally. Anyway, volatile never use anymore. The only real time we used to use it was for threading, and now there are better ways like atomics and locks you should never ever use volatile. It will just kill any optimizations you have and not do the thing you probably think it's doing. So yeah, never ever use volatile anymore. It's just an old relic that shouldn't be used. Modules, I haven't looked at modules yet. They're a new thing in modern C++, and I've heard good and bad things about them. Obviously, C++ should have a module system. It should have had it from the start. It's one of the big failings of C++. But whether they've got it right or not, I'm really not sure. But anyway, we'll see about that. Namespace aliasing. Oh yeah, when I talked about type defs, similar thing. I don't use them, but perhaps I should move over to them instead of using type defs. So yeah. Using namespace, I think I've talked about that before. I use all the time, but only in CPP files, never in headers, and only for my own namespaces. So nearly the end. Threadlocal, I don't think I've used that in my current code base. It's not as good as people think. People think, oh, it's the fastest way to do multi-threading because each thread has its own local stuff. Well, there's still an overhead to accessing thread locals, which is similar to accessing a global. So they're not free, and they're often as expensive as atomics or locking. So occasionally I use them, but not very often. Mutable, yes, occasionally use. Often means you've designed the code badly, but there are cases where it is useful. If you're interested, I can go through my codebase and just show you once or twice I've used it. Inline we've already talked about, and force inline. Okay, so some spam posts. 1 second. Okay, well I think it's time to stop anyway, so I'm being bombed by spam. So anyway, ignoring the comments for now. Like I said, next time we can go into more detail on any of these. I was thinking of doing, it's time, maybe next time we can do classes. We could probably do a whole stream on that. But do let me know if there's anything else you specifically want to go to. And maybe smart pointers. We might do smart pointers next time, because that's a one that a lot of people seem interested in. Anyway, we've gone over time this time, so I think I'll wrap it up. So yeah. The face is telling us to stop, I think. Right, so anyway, thanks for watching, and I'll see you again next week, and I'll let you know what I decide to do the stream on. So anyway, thanks for watching, and yeah, like I said, I'll see you again next week, and take care. Okay.